How can I measure steepness? We're going to compare the change in y over the change of x. And again, don't forget, this triangle is the delta sign. Ugh. I'm pretty sure that's Greek, and it means the change. So we don't really care what the numbers are. For instance, if the temperature one day is 50 degrees and the next day it's 57 degrees, we don't care that it's 50 and 57. If we're asking about the delta, we just want to know that it changed 7 degrees. So that's important to know heading into this. So in the previous lesson, you determined the growth and starting value of geometric tile patterns and made connections between the pattern, tile, and equation. In this lesson, you will use your knowledge to determine an accurate value of growth from a graph. During this lesson, ask your teammates the following focus questions. What makes lines steeper? What makes lines less steep? How is growth related to steepness? Where's the starting value of the line? So the table below represents a tile pattern. So here we go. Make a graph that represents this tile pattern on a resource page. I don't really want to use the resource page, so I will make an ugly graph really quickly. You can see my scale. I don't know how well this will work out, but I'll try. My scale should probably go to about 25. I don't know. Is that going to be enough? I feel like that. I don't know. Maybe I can put a space in. I should definitely probably pause this, but I guess you can suffer with me. That's pretty close to what I want. And then we'll just do that. That'll be better. So I will cut this. Again, I'm going to pause. This is ridiculous. So 0, 2 would be roughly right there. I should probably use my pen. It'd look better. So 0, 2 is going to be somewhere around right there. 1, 7 is going to be somewhere around right there. 2, 12, 3, 17, and 4, 22. That one's not in the best spot, but I don't know why I care. Okay, something like that. It should be more linear, obviously. Maybe I should have used the resource page. All right, should the points be connected? In this one, I would say no, because there is no figure half and figure 3/4, etc. I'd be curious to see if the book agrees with me. It looks like maybe they don't. So let's see. Yeah, okay. Difficult to imagine, but they still want us to draw the line anyway. So even though the book does agree that it probably shouldn't be connected. Okay, so they're saying draw the line anyway. So there we go. Again, not perfect. Should be. Those points should be on that line, but draw a continuous line to the tile pattern points. Extend the line to the edges of the graph and beyond. Oh, well. There we go. The line you drew models the growth of the tile pattern. Models are often imperfect, but they're useful in describing complex situations and for making predictions. What assumption does this linear model make about the tile pattern? Well, that it goes on forever, that it could be 0 and negative, that it could have a half of a figure and 1.5 of a figure, etc. Does the model in the previous problem appear to be a function? Yeah, it does appear to be a function. Each input has exactly one output. If it's so, write the equation in function notation. So I will say f of x equals 5x plus 2, right? Function notation. The 3 graphs below each model a different tile pattern. For each model, describe how the tile pattern grows and the starting value. So this one, it grows by up 2 over 1, so it grows by 2, and the starting value is 3. Actually, what I'm going to start doing is I'm going to use M and B. M is my growth. Let's get used to those terms. And B is my starting value. So here my growth is up 12 over 1. So, and my starting value is 9. And here my growth is up 1 over 1, and my starting value is 1, 2, 3. So we get the following starting value and growth and starting values. X represents the figure number, Y represents the number of tiles. Write the equation that relates. So here we'll say Y equals 2x plus 3. Here we'll see Y equals 12x plus 9. And here we'll say Y equals, you could say 1x plus 3, or you could just say Y equals x plus 3. It's assumed to be 1x there. Decide if the graph represents a function. If so, write the equation using function notation. So yeah, this appears to have one input and one output, one input and output, one input and output. So here I'll say f of x equals 2x plus 3. This one, let's call this one g of x equals 12x plus 9. And this one, let's call h of x equals 8x plus 3. So, okay, let's go ahead and close this and open the next one and pick up on 214. So 214 says the graph at right, also on the resource page, shows a linear model for a tile pattern. How's the line growing? Well, it looks like it's going up 27 and over 3. And we've already talked about this a little bit, but we're looking at the change in y over the change in x. So it's going up 27 for the change in y. And it's going up 3 for the change in x. So I would say it's actually changing 9 per 1, which makes a lot of sense. That would mean it would go over 1 and up 9, over 1 more and up 9 more, and over 1 more and up 9 more, so it would go over 3 and up 27. Okay, so that's that. 215, the triangle drawn in the graph, part B of problem 213 and 214 are called slope triangles. So these are the slope triangles right here. Slope is the measure of the steepness of a line if the ratio of the vertical distance to the horizontal distance of the slope triangle. So the vertical distance of a triangle is called change in y, red change in y, or delta y, while the horizontal distance is called delta x, or change in x. So when we look at this, this is our slope. Slope is either the m or the change in y over the change in x. I'll tell you, I don't like that they do it this way because it looks like x over y. I kind of like if they do it like this and they do delta y and delta x. I think it's easier to kind of remember it's y over x. When they do it this way, I think it's easy to think it's x over y, and I don't want you to get it backwards on that. It should be y over x, up and down, over left and right. So note that Greek, the triangle is the Greek letter delta that is often used to represent a difference or a change. So what is the vertical distance change in y for this slope triangle? Well, it looks like it's going up 2. And what is the horizontal distance? It looks like it's going over 1, 2, 3, 4. So calculate the slope of this triangle. Well, it's up 2 over 4. Well, we would simplify that and call it 1 over 2. So again, just to kind of give a look at that, what should happen is we should go up 1 and over 2, up 1 and over 2. You can see that's the same as going, I'll go a different color, as going up 2 and over 4, right? We get the same place. So we should be simplifying though. So what's the equation of this line? Well, it's y equals 1/2 x plus 2. Our starting point is 2 right here. 216, find the line graph at right with slope triangles A, B, and C. And again, you can see it's going 6 over 4 here, up 6 and over 4. Here it's going up 3 and over 2. That's the same. Well, what would it be here if we went over 3? It looks like we're going up 1, 2, 3, 4 and a half. And that makes a lot of sense, right? 1.5 times bigger, 1.5 times bigger, 1.5 times bigger. So it doesn't matter if your slope triangle is 6 over 4 or 3 over 2 or 4.5 over 3. Either way, we want the simplified version, which would be this one right here. So calculate the slope using triangles A and B. What do you notice? Well, I notice that the slope is 3/2, which, by the way, gets to an interesting conversation. I prefer you use an improper fraction and not call it 1.5x. If you want to call it 1.5x, that's fine. I just think as you go along in math, you're gonna realize the power of an improper fraction, especially with slope. I know I go up 3 and over 2, which makes it super nice. If it's 1.5, I go up 1.5 over 1. It's just not as clean as up 3 over 2. But like I said, my preference is here. I won't mark this wrong. It's just every year I have kids that don't actually believe that I'm okay leaving it like this. And like I said, you're going to realize Mrs. Baldwin says decimals are dead, which basically means that when you get into higher levels of math, you want precision, and fractions are precise. So what is the vertical distance change in y of the slope triangle C? Well, we already did that one. It was 4.5. Draw the slope triangle on the length with the horizontal of 1. So, all right, I'll go up 1.5 and over 1. What happens to the slope when the slope triangles are different sizes? Well, they simplify to the same thing, and that's important. All right, so 217 I think is the last one I do, but I'm guessing I need to open this to get the entire 217. So let's go here and see 217. It says Michaela was trying to determine the slope of the triangle or the line shown at right. So she selected 2 points where the grid lines intersect and then drew a slope triangle. Just so you know, these are known as lattice points where the graph meets the line. Like this right here is not a lattice point. If I zoom in on that, I think you can see that that point doesn't hit at a corner. We want to hit at a corner, and that's known as a lattice point. So it's easier to get the ordered pair here. 4, 6, and on this one, 8, 3. This point right here, it's 5, and I don't know, like 5 point something, but I don't know exactly because it's not on a lattice point. So make sure you look for lattice points. It makes it a lot easier to do these things. So Michaela was trying to determine the slope of the line shown at right, so she selected 2 points. Her teammate Cynthia believes the change in y is 3 because the triangle is 3 units tall, while her other teammate Essie thinks it's -3 because the triangle is 3 units tall. Well, think about it. It goes from 6 to 3. It's going down 3. So this change in 3 is right. Technically, you can make it happen with a 3, but then you got to make the other one negative. My advice to you is this. In America, we read from left to right. So my advice to you would be look at this thing from left to right. If it goes down, make your y negative because the x is always going to be positive going from left to right. So I would say that the slope here, my change in y is -3, and my change in x, again, I'm going from 4 to 8, is +4. So you can see here my y goes down 3, but my x goes up 4. And if you go from left to right, it's always easier to make the change in y, or the top part of the fraction, positive or negative, and the bottom part positive, I think. So when writing the slope, -3/4, as he wrote -3/4, she asked, are these ratios equal? So yeah, I mean, they are the same. It doesn't matter. The equation is -3/4. Think about it. If I have -3/4 written like this, that's like saying -1 times 3/4. Well, if I make it a fraction, I get -3/4. So these are worth the same. Again, I'm not saying you can't do it the other way, and I think the book is pointing out that you can do it the other way. I'm just saying for simplicity's sake, if you see a slope that goes up, make your change in y positive and your change in x positive so that you have a positive slope. However, if you have one that goes down, make your change in y negative and make your change in x positive so that you have a negative slope, and you won't be wrong if you do it this way.